Okay, so we took a look at measuring the width of this box. We determined that the average width that we measure is 3.73. Now, let's take a look at these measurements. You'll notice that we have a fair bit of variability in our measurements. In other words, if we're recording down to the hundredth place, which is the maximum capability, we're really suggesting a lot more confidence on our measurement than we have. After all, we have a lot of variability even in the 10th place. And so reporting out to the 100th place might not be the best decision to make. It might communicate more confidence than we actually have. So we're going to apply what we call rounding decisions to help us determine to what place value should we round our measurements to communicate the right amount of confidence. Now, just like with measuring to the maximum capability, reporting the proper amount of confidence involves place values for which you are certain and then one place value that is a bit of a guess. Okay, so that's the same rule for making maximum capability measurements. But again, what if our measurements are such that the maximum capability communicates too much confidence? So that's the case here. And so we're going to apply our rules of rounding decisions. Okay, so our rounding decision rules look like this. Keep all the place values that you would bet on, but keep the first place value that you would not bet on. That's consistent with our other rule of measuring, the maximum capability rule, which is that you are certain to the smallest line and then can guess one place beyond that. Again, certainty and then one guess. All right, so let's apply rounding decisions to these rules here, to this measurement here. So we're going to ask ourselves, would we, take a look at the average here, would we place a bet that the ones place, if we made this measurement again, that this one place would be a 3? I look up at the measurements that I have made, and I notice that every time they were a 3. So I'm very confident in that. I'm going to place a bet that the next place value would in fact be a 3. The next time we measure it, the ones place would be a 3. Now, let's go on to the 10th place. I have a 7 as my average in the 10th place. I'm going to look up here. Would I make a bet that the next time I measured, the 10th place would be a 7? Well, I have an 8, a 7, and a 6. It's not much varied, but it's a little bit varied, and I probably wouldn't place that bet that it would be a 7. So, in that case, my 10th place is the first place that I wouldn't bet on, and that's the last place that I keep. So I am going to round my measurement to the nearest 10th place. Again, make the bet here, wouldn't make the bet here, we're going to round to the tenths. 3.73 round to the tenths would be 3.7 centimeters. And that's how I want to report my measurement, 3.7 centimeters. And the reason why I want to do that instead of 3.73 is there's enough variability in these measurements that I don't really have any degree of confidence in the 100th spot. I report 3.7 because that communicates the right level of confidence in my measurements. That's the first example of applying what we call rounding decisions, knowing what place value to round your measurements when the maximum capability communicates too much confidence. In the next segment of the video, we'll look at another example.